Introduction to ECP. The purpose of Energy Communication Platform is to provide message delivery capabilities with additional key features such as security, reliability, integration, standard, transparency, portability. Security. All messages are transported encrypted. Only intended recipient of the message is capable of reading the message content. All messages are signed. The sender or receiver of any message can be unambiguously verified. On the communication layer, Secure Communication Protocol (SSL) is used. Reliability. Message delivery is guaranteed. It is guaranteed that any message that was accepted by ECP will be delivered if the recipient is available. Integration. The ECP functionality for sending and receiving messages can be integrated with a wide variety of technologies. Standard. ECP is the implementation of EN-SWI MODIS standard, which defines the technical aspects of communication between entities in the energy sector. Transparency. Any message transported by ECP can be tracked to gather reliable information about the state of delivery. Portability. ECP can be installed on most common operating systems. ECP delivers messages from a sender to a recipient. Both sender and recipient can be either a user or a business application. Users can connect to ECP through graphical screens. Business applications use a programming interface or file system folder monitored by ECP. The sender and recipient view ECP only through the available interface. Any internal complexity of the ECP network is completely hidden from the clients. The message transported between sender and recipient can be any text or binary data. Alongside the message, ECP also transfers message metadata containing information about sender and recipient, message type code, unique message ID, and sending business application code. Energy Communication Platform is composed of three main components: endpoint, component directory, and broker. From the user's point of view, the crucial component is the endpoint, which provides the user interface for sending and receiving messages and API for integration with business applications. The broker component provides intermediary messaging services to endpoints. The component directory component serves as a registry of an ECP network, managing the information about all connected ECP components, endpoints, brokers, and other component directories. Components use the component directory to look up addressing and security information about other components. The ECP network itself is a collaboration of a large number of components with the component directories in the center. ECP has a distributed architecture. It does not have any single central component. All component directories have equal responsibilities. Each manages its own part of the ECP network. The information about all connected endpoints and brokers is regularly shared between the component directories, so that endpoints and brokers connected to different component directories can communicate with each other. Messages are delivered between ECP endpoints according to configured message paths. The message path determines what route a message takes through the ECP network on its way from the sender to the receiver. Each endpoint is responsible for configuration of the message path for its incoming messages. The receiver shares its message paths with other components in the network through the component directory. Let's consider an ECP network with two endpoints, two brokers, and one component directory. Endpoint 1 configured a message path which defines that it receives messages of type A from broker 1 and messages of type B from broker 2. The message paths are stored in the component directory. The user of endpoint 2 wants to send a message of type A to the endpoint 1. Endpoint 2 performs message path lookup in the component directory and determines that the endpoint 1 wants to receive any message of type A through the broker 1. According to the existing message path, the message is delivered to endpoint 1 through broker 1.
Unicorn. Software everywhere.